Hey developers, Steven here from Be a Python Dev, and in this video I'm going to go over Python's 68 built-in functions. It might be more, it might be less at this time, depending on the latest versions. Generally it won't be less if you go from 3.7 to 3.8 because that would be a breaking change, so they would just add more, most likely. Whereas like 2.7 to 3.6, I think they moved a lot of built-in functions into other libraries, but not the case here. Anyways, that's not important. Let's just get into some of the functions and how often I actually use them. So we have a Visual Code IDE editor open here with a terminal running the Python CLI. It might just be easier to run some of the stuff here. And we probably need an example class. So let's just make class rectangle. We'll define the constructor, give it the self-reference, the y, and then self.x equals x, self.y equals y, and then we'll give a public method here called getArea, and this just returns x times y. So this is our example class, and let's test this out in the CLI from built-in functions import rectangle. That actually works. myrec. And this will just be a rectangle with sides 2 and 3. And then if we do rec.getArea, x is not defined. Duh, because it's self. Whoops. Sorry, guys. And girls and any other people that are watching this video. So this is saved. Let's just update our terminal reference here. So from built-in functions import rectangle. Rec equals rectangle sides 2 and 3, and then rec.getArea 6. Yay. All right, anyways, so the first built-in function is the absolute function. This just returns the absolute value. You don't need to import anything. That's why these are called built-in functions. They can be called anywhere in your Python code. So if you have the absolute value of -5, just equals 5. So that's useful with different math operations. The next one is all. So all will evaluate a bunch of conditions that only returns true if all of the conditions are true. So this is, oh, I guess it's it takes an iterable. So it has to be like this. So these are obviously not all true, so it's false. So you can have like all true, 1 equals 1, 1 equals true, because 1 does equal true, and these are all true. So that's how the all operation works. It's useful if you have like a function that returns an iterable of conditions, and you just want the master level binary, are all of these true? If so, do some stuff. So you can do if all, and then throw in an iterable. Next one, any. Any is similar to all, and it returns true if any of the values are true. So false, false, 1 equals true, that'll be true. So it's kind of the opposite of all, where any only returns false if everything is false. Ascii, return printable characters of an object with escaping. Interesting. So it casts rec into the Ascii object. Binary, return a binary string for an integer. So binary 10 equals 0b1010. So this is the 2 spot, this is the 8 spot. So 8 plus 2 equals 10. Bin 10 equals 0 bytes 1010. And then I think the b denotes bin. So I think there's an equivalent hex function. So if you do hex 15, it should be f, I think. So 0xf. So f is the equivalent to 15 in hex, and x shows that this is a hex representation of a number. Similarly, there's a built-in function for oct. So oct16, I think, would just be 1 1. I don't know. I can't remember. Oh, 0 2 0. So yeah, this would be. This goes up to 7, and then this goes up to 24. I think that's how that works. Yeah, this goes up to 24. So 2 times 8 equals 16. That's why this is a 2. Oh no, this will go to 56 then. Yep, that's how that works. So 56. So 0 0 7 0 would be 56. Sorry about that, but that's how that works. So you have your bin, hex, oct, allows you to cast integers into numbers that computers know how to work with. Given that computers store things in bytes and binary, such as this equivalent, and hex is an easier way to digest a byte because a hex is just a single byte. So f equals 11111111. I think, right? Yep. Or no. It's just a 1111 is a f. Next, callable. Returns true if the object is callable, otherwise false. So I think we can do a callable rectangle, and that is callable because you can construct it. So useful to kind of introspect some of your code that's going on in the thing. Okay, I am recording. I also meant to play music when I was doing this. Sorry about that. We'll just keep going with a lecture type thing. If you're following along, great. If you've been bored, I'm sorry. I'll know that by looking at the metrics of this video. But yeah, there's a lot of built-in functions that are super useful. Next one is character. So the CHR function returns the character equivalent of the Unicode integer. What does that mean? So I guess 11 equals /x 0b. Can you do this? Nope, it only returns integer values. I've never used sure, I've never used callable. I have used any and all a lot, actually. What else have we talked about? Absolute value. I don't do a lot of math operations, so I don't personally use that a ton. But if you're probably more data science and you're doing data formatting, maybe use absolute value more often, or in science fields in general. I could see it being useful. Class method returns a class method for the supplied function. I don't know what that is. I'm not even going to try to explain how that works. Compile source into code. Don't see that used very often. Also not very useful. Compile. Yep. Not even going to try to explain how that works, but there is a built-in method for compile. Missing required argument source. I don't even know how to create a source object, to be honest, guys. Next one, complex. Returns a complex number from string or number. I guess if you have 15, the complex version of 15 would just be 15 plus 0j. So negative 15, would that be 15 plus I? No, it's just negative 15. I don't remember complex numbers very well, to be honest. I thought they were a way to represent imaginary numbers. So what is like complex 15 plus 1j? It's 15 plus 1j. Okay, if anyone remembers how to what complex numbers are useful for, let me know in the comments. I'd appreciate that. I personally forgot. I know it's definitely math related, but yep. Del attribute deletes an attribute from an object. Well, we have an object. New rec equals. See, this is why we made the rectangle class in the beginning. And then I think you can do del attribute new rec like .x. Maybe it wants the object and then it wants what you're deleting. So then if we do new rec.x, rectangle object has no attribute x, but we know it should have x because it's defined here. And just to show you that this isn't a crazy thing, so you can see our y equals 4. So that's kind of how del attribute works. Don't use that very often either. Dict, super popular. How do you declare an instance of a dictionary with this? I normally do like dictionary x, y, like x equals 1, y equals 2. And this I think will overwrite dictionary. Will it? No. Sorry. Colons. X is not defined, obviously. So now we've overridden dictionary, so now we can't actually do this. I don't want to deal with this. This is why Python is kind of dangerous, because you can override default functions. So we're just going to exit, go back into Python. We lost our rectangle. I'm going to rename this to rectangle. Rename rec. From rec import rectangle. Don't think we need to refresh our session to get the instance. New rec. We're gonna be very good at making rectangles at the end of this. Where are we at dictionary? I think, is it like this? Dictionary expected at most 1 argument. Got 2. How do you create a dictionary? The dictionary method, guys. This is super embarrassing. We'll just quickly look it up in another window. Yep, that's how I normally use dictionary. Also how I normally use dictionary. Oh, guys. Guys. And girls. How to make Python dictionary with dict. Again, that's the format I'm used to using. It takes keyword arguments, I guess. But it said expected at most 1 argument. It's got 2. Oh, I guess it just serializes this as a kwarg. Yeah. So it turns those into keyword arguments because it has the equal assignment, and then that casts it to a dictionary like that, which is almost easier than doing the kind of like JSON type notation. Okay. Use dictionaries a ton. Super highly useful. Dir returns a list of names in the local scope or attribute of the given object. So if we do dir rectangle, I think it tells us what's all in the rectangle method or the rectangle object. So it has a set attribute. It has the these are all the magic methods that come like standard on basic Python objects. And then it has the function that we declared, the get area. So you can use dir to do like reflection-based coding. I've used it somewhat, I guess. This is still kind of long. Maybe I'll break this up into a couple videos. Div mod returns the quotient and remainder for integers and floats. How does that work? Div mod 14.3. So 3 times 4 equals 12 plus 2. So yeah, if you need to get an integer and you need to get remainder parts, you can use div mod. Cool one there. Enumerate, another kind of very useful. So for I in enumerate. So this gives integers. Print I. So this will be 1 and 2. Actually, that didn't do what I expected it to do. Oh, it gives the value and it gives the index. So it returns a tuple for the iterable with the indexes. So it'd be for I val in enumerate. Another pretty useful one I use semi-regularly. Eval returns the results of an evaluated statement. So I think you can do eval 1 plus 2 or eval 1 times 3. So actually, so you see a lot of people making calculators, like input an expression. So this would be the expression. You can just use eval to kind of do that. Or you can say, you know, if the operator equals multiply, then do this operation. So it's kind of a simpler way to create a math-based input. Exec for dynamic execution of code. So exec some code, invalid syntax. So I think you could actually just do exec. Is this a string? Print 2. Yeah, so it takes a string of code and then it runs the code. So if you have a program that's taking some value from like a web application, I guess, so you can write code in a web application and then you can exec it. But the problem with that is if your code is sys.delete like the root directory, you probably don't want to exec some unsafe code from the internet. So be careful with exec filter or exec function. Next one is the filter function. Constructs an iterable of values that returns true. So this takes a list. Is it something like this? So if the index equals 3, bool object is not iterable. So is it the filter expression first? Yeah, so it takes a filter expression and then it takes an iterable. Values that return true. Cool. Float returns a floating point number. So if you have float 12.3, turns it into a float. So if you get input number and then you cast that to a float, you know, the input by default is a string and then you can turn it into stuff. Format returns input as formatted by a custom specification. Yeah, so if you have something like 2.333 and then you can do like something like number 2, and then it'll format it to 2 decimal places. This is not the correct syntax and this won't work. I actually kind of screwed myself. There, now I got it to break. Cool. Has attribute, returns true if the object has a specified attribute. So I think you can do has attribute, pass in our rectangle object, and we can say x. False. X is not defined. Maybe it's not a class object, so maybe this has to be an instance. So then we can do has attribute myrec x. True. There we go. So this instance has an x property. That's true. So more stuff for introspection and reflection of code. Hash returns hash integer keys for an object. So we can hash myrec and it'll give it some cool value. And then you can do like a module of that. Hash mod 3. Hash mod 3. Hash. You do mod. I thought it was this. Mod in Python. It is. Unsupported operand in type. Oh. I guess I just need to read the error. Mod 10. So if we have a, let's do a quick hash table. My hash table equals values of arrays times 10. Show you this works. So now we have an array of one slot. Okay, it's supposed to be this. Now we can do this. And then you can do my hash table insert using a hash function hash myrec times or mod 10 mod 10. So that will insert and then it'll insert myrec there. So now we can print my hash table, and you can see we have a hash table of 10 objects with this in the 9th slot based on our module and the size of the hash table. Pretty cool, right? Pretty cool. And that's how you can make your own custom dictionaries too. I have a video on that. Where are we at now? Help. Invokes the built-in help system. Really? Let's see what that does. Okay, it shows that it's a class rectangle. It by default inherits from the built-ins object. You know, its constructor is xy, and it has an init, and there's a more, and it also has a get area, and then some of the default functions. And then I'm sure if you did a doc string, the help function would probably show the doc string. So that's kind of cool, actually. The next one is hex. We talked about hex already. ID returns the unique ID of an object. So ID myrec. Python creates things and gives them internal IDs inside the Python runtime. I don't use this a ton, but it's super useful if you're creating a lot of instances of objects and you want to store those objects in a collection. Input, we kind of already showed that. It's a way to get input from a user. Foo. So foo. And then we can say foo's this, and then we can print x, and x just shows our value as a string in the space since we typed a space. So you'd actually want to do something like this if you're trying to get input from a user, and then you get this and then x. You probably want to use the same consistent naming between x and your input, or some kind of meaningful prompt that a user would be able to relate to. Integer, cast numbers, or cast a string into an integer value, or it can cast a float into an integer value. So the built-in cast functions are pretty nice, super useful all around, every single one of them. Is instance, and is class. So I think you can do is instance myrec of rectangle. So is myrec an instance of a rectangle? It is. Is instance myrec a string? String is not defined. Can we just import string? Doesn't work. Maybe it's a str. Str is not defined. Okay. Lowercase s. Myrec is not a string, but hi, this would be a string. So you can do a lot of kind of type checking along the way. Generally, Python uses duck typing, so you don't see is instance as often, where instead you just assume behavior and then throw exceptions if it doesn't follow that behavior. Is subclass. So another reflection-based function. So is rectangle a subclass of object? How does that work again? So if you had a square, and a square is a inherits from rectangle, then square would be a subtype of rectangle. Python object. Is it just this actually? Okay, it's just plain object. So is rectangle a Python object? True. And since it is, we know that it has the same methods that an object does. So based on that value, if we know Python objects have dictionaries, you know, you can print the dictionary and you can show the mapping proxy of all the dictionary values, which shows our get area function and defines it as a function. So yeah, yep, some more introspection stuff there. Wow, 25 minutes. This is a long lecture, I guess. Is subclasses where we were? Next one, iter. Just iterates over a set of tuples. I'm not going to go into that. Length. So length. This one I use very frequently. This will be 3 because it tells you how long a list is. Usually in like C# and Java, you can do like list.length, but in Python you do the built-in length function. And then you can also do this on other iterables. So since a string is an iterable, you can get the length of a string too. List creates a mutable list. How does this work? Does this just take again, I don't remember how this works. I normally do my list equals 235, and then is instance my list list. True. So you can see my list is a list, and you can create lists that way. Yeah, I'm not going to spend a bunch of time on that. Locals returns a dictionary of names, methods, and classes locally. So what is local to what we're running right now? All these are local. And I think you can do that based on like a working directory in a class, and you know, just shows everything active in the runtime. So in the runtime, we create a new rec. So you can see new rec here is defined as a local, and then my rec. So I didn't need to create my rec. I could have just ran locals and saw that I had a object in memory already and just use that. We also created my list, and we also created an X. So it's a cool debugging tool. Map applies a function to each item of an iterable. So you can do map do stuff iterable. I'm not gonna go too much into that. I don't use it a ton. It's good for functional type programming, but I use list comprehension more. Slightly easier. Max. So if you have max of 2, 5, 6, 3, this will return 6. So the max value. Super useful if you're doing like heavy algorithm things and you have like a long list. Memory view returns a memory view object from an argument. Memory view myrec. A bytes-like object is required, not rectangle. Okay. Obviously don't use this one very often. I haven't seen it a lot, but it's there. Min, the inverse of max. Where, yeah, I know that's wrong, but now we'll return 2. Also very useful. Next returns the next item from an iterator. If you're creating a lot of your own generators that return iterators, use next pretty often. I don't. Returns a feature list object. Blank obj equals object, which you can also inherit from object, which I think I showed you that. So blank obj.x equals 23. You can't do direct assignment, I guess. Okay, well, not hugely useful. Next one, the octal value. We talked about that. Cast an integer to an octal string. Open. So A lot of times you'll do like with open rec dot py as f print f dot readlines. So you can see this is all the stuff that we wrote inside that Python file. And we're using a context generator here. So once this goes out of scope, it'll automatically close this open object. Otherwise, you would have to do like f equals open and then f dot close once you're done doing stuff on it. I'll actually show you what that looks like. F equals open. So you can open stuff to read it. You can open things to write to it. By default, it just does read. So same thing as what we did earlier. And we didn't actually need to print it because the Python CLI will just dump it as output. ORD returns a Unicode integer for a string. Foo. Expected a character. So the ordinal value of f equals 102. Is that constant? Does that have to do with the Unicode value? Unicode table? So what is f in Unicode? F in Unicode is 66. HTML code is 102. So the ordinal, I guess, is the same as HTML code. Cool stuff. We're learning. Power returns the exponent. So we do pow 22 equals 4. Pow 3 5. 3 to the power of 5 equals 243. I think it's just the same as this though. No. This is a bitwise operator. Okay. So I guess to do powers, use the pow function. For some reason, I thought it was this, which I'm wrong about. I can admit to being wrong. Perfectly fine with that. The print function, we've showed this a lot already. You should be super familiar with print. Yep. Property returns the property attribute for a class. We're not going to talk about that since we've done other things kind of similar to it. Range. So if you have a list of 10 items, well, actually, no. Range is something different. This will create a iterable. So for I in range 10, you can also do backward ranges. Print I. So this is how to do like a standard for I is less than 10 I plus plus operation in Python using range. Repr. So this is a way to show a string representation of an object if it has a repr. So if we def repr, I think you need self. Now, obviously, the rectangles that we've created already aren't going to have this, but it'll show like a default representation. But now that we created this repr function, we can re-import our rectangle from rec, import rectangle. So now we have a new reference to what a rectangle is. So new rec equals rectangle 3.6, and now we can do repr new rec. That still didn't work the way I thought it did. Let's see here. From rec import there. Okay, so I guess I did have to flush the session and get a new rectangle. So now you can see we have a custom representation, super useful for displaying information that you want to about an object if you are making a lot of object-oriented programs. Reversed returns a reverse iterator. So let's say iter equals 1, 4, 5, 7, 6. Reversed iter. And now we show iter, it's still the same thing. You have to reassign it, so our iter. And it returns an object type, I guess. I thought it would just, no, it returns an iterator. So you can do like .next and the generators and all that fun stuff that I don't do very often, to be honest, in procedural Python and web application programming. So now we can show our iter, and it's still a list iterator object. So for r in r iter print r. So now you can see the reversed representation as a iterator object that you can do .next on to get values, depending on where your iterator pointer is. Round returns a number rounded to a specified precision. So if you have 23.456, I think you can do round. I'm just gonna assume that it works like this. So yeah. So that's actually pretty useful. Set creates a set type object, which is very similar to a dictionary, except it does not create values and it just stores keys. And you cannot create duplicate keys. So my set equals set, my set.add3, my set.add4, print my set.add3. So if you try to add things twice, it only shows it once. And then you can do del my set4. Set object doesn't support item deletion. Okay, another thing, sets are immutable, I guess. Or maybe I'm wrong. Maybe you can do my set remove, which you can totally do that. With a dictionary, you do del key. Does dictionary have remove on it? Test equals test. Yeah, dict object has no attribute remove. So in this case, we do del test3, and now test is an empty dictionary. So you can see some of the differences between set and dictionary there. Set attribute. That's an attribute for an object. So maybe if we do, my obj equals that blanked object that we were having problems using earlier, we can do set attribute my obj x 5. X is not defined. Object has no, okay. I don't know how set attribute works apparently. Don't use it very often. Returns a slice object from another object. Test equals 1, 2, 3, 4. So this is a list object. Slice test 2. And that creates a slice object and has none. Okay, that's interesting. Don't really know how that works that well. Test, we'll just overwrite this 1, 4, 6, 2, -1. To talk about the next function, which is sorted. So sorted test equals sorted test, and we'll just print that, and you can see now our array is sorted. Super easy. I think you can define what the iterable is here, and if you have like a 2-dimensional array or list of 2 tuples. You can sort it based on different conditions. So if we do test equals 1 3 2 1, so obviously test is sorted on the x value, but it's not sorted by the y values. So say you wanted to sort it based on that instead, like if that was an end time instead of an integer, I can do sorted test lam. I don't remember how to do lambdas. It's just lambda x. Sorted by this value. I think it's like this. Sorted expected 1 arguments. Got 2. I could have sworn you could have. All right, hold on. Let me see here. Python sorted function. Key. So maybe it's key equals lambda x x1. Yeah, okay, cool. That actually does work. So you specify the sort key as a key value quark, and then we create a what is this called? And lambda nameless something, but we're specifying to sort based on the second value of the wow, I'm blanking on words here. The duplexes, the tuples, sort on the second value and the tuples. So yep, sorted, super useful. Also use that a ton based on timestamps and things like that. We are almost getting towards the end of this. This has been a huge, long, super video, and I guarantee no one is still watching. But if you are a trooper and you really care about built-in functions. All right, so we talked about slice. We did sorted. Static method returns a static method for a function. I don't use that a whole lot. Probably not very useful. So, yep, we're just not going to talk about that. Cast things to strings. I think you can also do this with. So now that's a string value instead of an integer. So you can use that for output. Next is sum. Returns the sum of an iterable object. This one is super useful. So if we have, I think we had test already. Ints equals 1 3 5. Just by looking at this, we can see the sum is supposed to be 9. So sum ints equals 9. The super function, you use this when you have like inheritance. So if square inherits from rectangle and you want to initialize rectangle when you initialize square, you would put this in the constructor function. Tuple creates an immutable sequence object. Actually, I don't know how to do this. X2, 4, 5. Tuple expected at most 1 argument. So if we take a list, okay. So you can cast a list into a tuple, and now as a tuple, you can't add and insert and change values in it. So if we try to do rtup equals tuple, put in a list, and then rtup. So this would be perfectly legal to do on a list, but you can't do it on a tuple. So it does not support item assignment. In some ways, a string is kind of like a tuple. So in that way, our string equals hello world. And let's say we want to change the the very first letter to be fellow, like fellow world. So string object does not support item assignment. Does that look familiar? Looks very familiar. Where are we at next? Type. So our string, class equals string. Type is pretty useful. It's used high. Vars returns the dictionary attribute for objects that have them. So I think we have a, we can use the locals function again, see how useful that is. So we have a new rec. Apparently this shows the repr. So yeah, when you do locals, if you have a instance of a class that has a repr defined, it shows the repr on it. So we can see what this new rec actually is. So we can do vars of new rec. And it shows the properties and what those properties are assigned to, which is instantiated here at the top. So another pretty useful function for doing code introspection and modifying code at runtime and things like that. Zip. Zip is pretty cool, except I don't know how to use it. Zip Python. Let's look this up real quick, guys. Oh, it combines two lists into an object. So if we have A equals A, B, and then we have the B list equals 1, 2, we can zip A and B. And then how do you do this? Oh, you have to cast it to a list, actually. And then you need to assign it. Yeah, so let's just do a result of zip A and B. Print list result. You can see it combines all the values from the list into tuples. So A1, B2. Useful in linear algebra and other types of math-based things. I don't use it a lot in web application and procedural coding, but you can see how that would potentially be useful. And that is all of the built-in functions from this page that I'm looking at right here. Holy cow, where did it go? No, where did it go? I don't know if I'm gonna leak something, so yeah, let me let me just send 68 Python built-in functions. All right, so this was the page that I was looking at here. So you can see all of the built-in functions, and we talked about them, which ones I use pretty often, which ones could be useful, like ID. Input, super high used for interactivity when you're making CLIs. And again, if you want to find more built-in functions, just go to python.org and look at the documentation, because 3.10 may have added stuff that's not in 3.7. So I hope this has been useful and not just a big, long, boring lecture, but I hope you guys have learned some stuff, and see you guys next video.